All right, this is Quadratic Formula Part 1 notes. So this kind of introduces the quadratic formula. On the front page, we're going to really focus on this part that's under the radical, and we call that the discriminant. On the back side, we're going to focus on the whole formula. So the quadratic formula helps us to solve quadratic functions like this, where the highest degree is a 2. We were solving these by factoring, but factoring doesn't actually work every single time. Not every quadratic function is factorable. However, the quadratic formula does work every single time, so that's why it's so great. I am having you guys memorize this formula, so on the quiz you're going to have it memorized, and that's because the TN Ready doesn't provide you this formula, so it's going to be helpful to memorize it. In class we used, I played a YouTube video with a song that goes to this, so you may want to look that up, and that'll be helpful in memorizing it. So like I said, we're just going to focus on the discriminant first. The discriminant is equal to b squared minus 4ac. And that tells us some stuff about the solutions, what x could be equal to. So if the discriminant, if b squared minus 4ac is less than 0, a negative number, our graph could look something like this. And this is just an example. But if it's a negative number, that means we're not going to have any x-intercepts. Notice this does not go through our x-axis. That means there's no solutions, because when it does go through like these, those are where our solutions are. So if it doesn't go through, that means there are no real solutions. There are some imaginary solutions that we'll get to, but right now we're just focusing on the real solutions. In this case, no real solutions. If our discriminant, b squared minus 4ac, is equal to 0, our graph could look something like this, where we have exactly one x-intercept. So that means we have one real solution. One real solution. And then finally, if our discriminant is greater than 0, a positive number, our graph could look something like this, where we have two x-intercepts. And so that means two real solutions. So it's helpful to know how many solutions we're looking for when we actually start to solve for x. So down here, we're going to practice solving for the discriminant. And we're going to use that discriminant to determine how many real solutions each quadratic function has. So let's start with number 1. And we're going to get in the habit of always starting by finding a, b, and c. We did this for factoring as well, and it's the same process. A is always in front of our x squared value. Even though we don't see something there, it's understood to be a 1. B is always in front of the x value, so that's a 4. And C is always our constant that doesn't have a variable attached, so that's 4. And you can see they go in order, A, B, C. Okay, and so we're going to plug this into our discriminant. And remember, we said our discriminant is equal to b squared minus 4ac. So I'm going to rewrite that. B squared minus 4ac. And so I'm just going to plug that in, and every time I plug in one of these values, every time I substitute one in, I'm going to put it in parentheses. So instead of b squared, well, b is equal to 4, so that's 4 squared, minus 4 times a, well, a is 1, times c, and c is 4. So at this point, I would honestly recommend you just plug this right in your calculator in the interest of time. When you do plug it in your calculator, make sure you're using the parentheses. But you can also do this by hand. I don't have a calculator at home here, so I'm going to do these by hand. So 4 squared, that means 4 times 4, that's 16. I'm going to bring down my minus sign, and then I have 4 times 1 times 4. 4 times 1 is 4, and then that times 4 is 16. You can also think of this as negative 4 times 1 times 4, and you still get negative 16. So there's 2 different ways to think about that. I know that does throw some students off. So 16 minus 16 gives us 0. Okay, our discriminant is equal to 0. So what does that mean? Let's see. If our discriminant is equal to 0, that means we have one real solution. One real solution. And you can shorthand this if you want. So we're going to do the same process for number 2. I'm going to start by finding A, B, and C. So in this case, A is going to be 2. B is negative 8. Not positive 8, but negative 8. And C is 10. So we're going to plug this into our discriminant, b squared minus 4ac. And every time I plug in one of these letters, I'm going to put it in parentheses. That way you avoid any sign errors, so it's just good to get in the habit of doing it every single time. So we have negative 8 squared, right, because b is negative 8, minus 4 times a, which is 2, times c, which is 10. Again, I'd recommend just plugging this right in your calculator, making sure you use those parentheses. But if we do this by hand, let's see, negative 8 squared. Negative 8 times negative 8 gives us a positive 64. I'll bring down my minus, and we have 4 times 2 times 10. Well, 4 times 2 is 8. 8 times 10 is 80. And so 64 minus 80 gives us a negative 16. Okay, so a negative number. What does that mean if our discriminant is a negative number? Less than 0, that means we have no real solutions. So we will have some imaginary solutions, but no real solutions here. Going on to number 3, I'm going to start the same way. I'm going to find A, B, and C. In this case, A is 2, B is negative 5, and C is negative 3. I'm going to plug that into my discriminant, b squared minus 4ac. So b is negative 5 minus 4 times 2 times negative 3. Okay, so let's see, negative 5 squared. Well, negative 5 times negative 5 is positive 25. And so I'll bring down my minus sign. Now I have 4 times 2 times negative 3. 4 times 2 is 8. 8 times negative 3 is negative 24. Well, what happens if I'm subtracting a negative? That's the same thing as adding. And you could have thought of this as negative 4 times 2 times negative 3, and that would have gotten you that positive 24, which is equal to a positive 49. So we have a positive discriminant. If our discriminant is greater than 0, a positive number, we have 2 real solutions. Okay, and then let's look at number 4. I'm going to start the same way. I'm going to find A, B, and C. You may want to pause the video and try this on your own just to make sure you understand But in this case, let's see, 4 is A, B is 12, C is 9. I'm going to plug that into B squared minus 4AC. So that'll be 12 squared minus 4 times 4 times 9. Notice I put parentheses around my A, B, and C. Okay, so at this point I would just plug in the calculator, but I'm going to do it by hand. So 12 squared is 144. Bring down my minus sign. 4 times 4 times 9. Well, 4 times 4 is 16. 16 times 9 might require a calculator, but that ends up being 144. And so 144 minus 144 gives us 0. A discriminant of 0 means we have one real solution. Okay. So now that we know what types of solutions we're going to have, on the back side we're going to use the entire formula. So the whole formula, not just the discriminant. We're going to use the whole formula to actually solve for x, to find those solutions. So on the back side, I provide you the steps, about 4 steps here to use the quadratic formula to solve a function, quadratic function. I'm just going to jump right into number 1 though, and I think that'll help. But if you need to read those steps, it's the same thing that I'm going to do for each of these. Okay, so for number 1, we're going to start the same way that we were on the front. We're going to find A, B, and C, because essentially what we're doing is finding A, B, and C and plugging it into our formula. So in this case, A is 1. You know there's a 1 there. B is -5. And C is 4. So I'm going to be a little extra here and write every single step down. So I'm going to start by rewriting the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac over 2a. So that'd be a good time to kind of quiz yourself to see if you memorize that already. Once you get good at these, you don't have to rewrite this every time. You can just go ahead and start plugging in your values, because that's what I'm going to do next. I'm going to take these values of A, B, and C, and I'm going to plug them right into my formula. So everywhere I see an A here, I'm going to substitute in a 1. Everywhere I see a B, I'll substitute in a -5. And everywhere I see a C, I'll substitute in a 4. So I'm going to do that now. So let's see, we have x equals -b, which is -5. And you can see already a negative, we know that's going to turn positive eventually here. Okay, so that's b squared minus 4 times a times c, and this is all over 2 times a. So right now this looks a little crazy. What we want to do is start by simplifying what's under the radical. We're going to simplify that discriminant. And we're always going to start that way. That just makes simplifying this whole thing a lot easier. So I would just plug this right into my calculator, but also we can do this by hand. We know -5 squared, that's positive 25, and we're subtracting off 4 times 1 times 4. Well, 4 times 1 is 4. 4 times 4 is 16. So we have 25 minus 16 is equal to 9. Okay, so now I can rewrite this, clean this up a little bit. We have x equals, I'll deal with this part now. A -5 makes it a +5, plus or minus the square root of 9 over 2 times 1, which is 2. Okay, we can clean this up more. The square root of 9, we happen to know that one. That's a perfect square. We know that's equal to 3, since 3 times 3 gets us 9. That's one we have memorized. If we didn't have it memorized, if it wasn't a perfect square, we would have to simplify it using a factor tree. So that's why we did that lesson before this. Okay, from here we can go ahead and get our 2 real solutions. We know we're going to have 2 real solutions because our discriminant is a positive number. Okay, so let's see. I'll write this out. And this is where the plus or minus sign is going to come into play here. Some of you haven't seen this, but we read this as plus or minus. So for one solution, we're just going to use the plus sign. And for the other solution, we're just going to use the minus sign. So let's focus on the plus sign. We're going to do 5 plus 3 divided by 2. So 5 plus 3, that's 8, divided by 2. Well, that's going to give me 4. The 8 came from 5 plus 3. The 2 I just brought over here, divided by 2, gave me 4. For this one, this solution, we're just going to use the minus sign. So we're going to do 5 minus 3 divided by 2. Well, 5 minus 3 is 2. We're dividing by 2. 2 divided by 2 gives me 1. So those are my 2 solutions, 4 and 1. So I consider that an easy quadratic problem. Since we were working with nice whole numbers, we didn't have to really simplify this radical with a factor tree. It just kind of worked out nicely for us. But they're not all going to work out quite this nicely. So let's take a look at number 2 here. I'm going to start the same way by finding A, B, and C. So in this case, A is 2, B is 8, and C is negative 8. And again, I'm going to rewrite the quadratic formula. You don't have to. You can just start plugging in, but I like to show every single step, and it helps from making errors sometimes. So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So I found my a, b, and c. I wrote my formula. The next step is going to be plugging in these values into my equation. And remember, every time I plug one in, I'm going to put it in parentheses so I don't make any sign errors. So we have negative b, which is 8, plus or minus the square root of b squared minus 4 times a times c. I'm just plugging in a, b, and c. This is all over 2 times a. So everything in parentheses, that's an a, b, or c that I'm pulling from over here. Okay, so right now it's looking a little crazy, but we're always going to start by simplifying the discriminant. We're going to simplify the stuff under the radical. And we can do that by just plugging it right into the calculator. So when you do plug this into the calculator, or if you do it by hand, you're going to get 128. And that's kind of a big number, but we'll work with it. So I'm going to clean this up a little bit. We have x equals negative 8 plus or minus the square root of 128, all divided by 4. Okay, well, the square root of 128, it's not a perfect square. Like for the first problem, we knew 9 was a perfect square, so we could easily get 3. This one's not a perfect square, so I'm going to have to do a factor tree off to the side here. So 2 factors that give me 128 would be 64 and 2. And then I could break that into 8 and 8. And remember, once we hit a pair, we can actually stop and circle it. So I could have kept going on the 8s, done 4 and 2, 4 and 2. You'd get the same answer though. So a little shortcut is once you hit one of the pairs, you can stop with those. If I could still break this 2 down, I would, but in this case, that's going to be a single. So this simplifies to be 8, couples go out, square root of 2, singles stay in. So I can replace this square root of 128 with 8 square root of 2. So I'm going to do that next. So negative 8 plus or minus, instead of the square root of 128, I'm going to put 8 square root of 2. And this is still over 4. Okay, and this is looking pretty good. It's not a bad answer so far. Some of you at this point would be like, hey, can't we simplify a negative 8 over 4? Isn't that negative 2? And the answer is yes. But we can't just simplify this without also simplifying this 8 over 4. This 4 belongs to that negative 8 and this positive 8 squared root of 2. And so that's why we do this triangle method, this upside down triangle looking thing that says we can't just simplify 2 of these. We can't just reduce one fraction. We have to do all 3 numbers at the same time. We have to reduce this fraction and this fraction at the same time or nothing at all. So we do this triangle and you want to kind of find the GCF. What is the largest thing I can divide all 3 numbers by? In this case, it's going to be 4. So I'm going to rewrite that. So let's see, negative 8 divided by 4 is negative 2. I'll bring over my plus or minus sign. 8 divided by 4 is 2. I'll attach my square root of 2. And then 4 divided by 4 is 1. So that's a perfectly acceptable answer. Keep in mind, anything divided by 1 is just itself. So I don't really have to have this divided by 1. So an even better answer would just be the numerator, negative 2 plus or minus 2 square root of 2. And hopefully you can see how there's still 2 real solutions. Our discriminant was a positive number. So we knew we were going to have 2 real solutions. One real solution is negative 2 plus 2 square root of 2. The other real solution is negative 2 minus 2 square root of 2. I can't combine these like I did in the first problem where I got those 2 nice looking answers because we can't combine rational and irrational numbers. We can't combine, whole numbers with radicals is what I'm saying. So we thought we just leave it like that. Okay, let's look at number 3. So we're going to do this the same way. I'm going to start by finding A, B, and C. And after we do a lot of these, it starts to get a bit easier, but these are long problems. Okay, so for this one, A is going to be 1, B is 6, C is negative 4. Again, I'm going to rewrite my quadratic formula. Negative B plus or minus the square root B squared minus 4AC over 2A. Next step would be plugging in A, B, and C. And when I do, I'm going to put them in parentheses. And that's over 2 times A. At this point, it always looks a little crazy. I have a lot of students that will get stuck. They feel stuck at this point because it just looks a little overwhelming. But whenever you get to that point, remember, we always want to start by simplifying what's under the radical. Once we clean all of that up, this will start to look a lot nicer. So I would just go ahead and plug this into my calculator. 6 squared is 36. Let's see, we have negative 4 times 1 times negative 4. That gives us a positive 16. So 36 plus 16 is going to be 52. I'll just plug it in my calculator. Just don't have one on hand right here. Okay, so now we can clean this up a bit. We have x equals negative 6 plus or minus the square root of 52. all over 2 times 1, which is 2. Okay, unfortunately, the square root of 52 is not a perfect square, so we're going to have to do a little factor tree. So I'll do that off to the side here. Let's see, 2 numbers that give me 52, that multiply to give me 52. I can use 26 and 2. And then I can use 13 and 2. 13 is prime, so we'll have to stop here. I'll circle my pairs, underline my singles. Remember, couples go out, singles stay in. So now instead of the square root of 52, I can replace it with that 2 square root of 13. Where should I do that? So let's see, we have x equals -6 plus or minus 2 square root of 13 over 2. And again, this is a pretty good answer, but we can take it one step further. I know -6 divided by 2 is -3. I can simplify that. And I know 2 divided by 2 is 1. I can simplify that. We can't just do one fraction without doing the other. So we do this upside down triangle and simplify all 3 numbers at the same time. So the GCF, the largest number I can divide all 3 by, is 2. So I'm going to do that. And then I'll write my final answer right here. So let's see, -6 divided by 2 is -3. I'll bring over my plus or minus. 2 divided by 2 is 1. I'll attach my square root of 13. 2 divided by 2 is 1. Again, we don't have to keep the divided by 1 because anything divided by 1 is just itself. And also, I don't have to have this 1 in front of the radical. It's always understood to have a coefficient of 1 anyway. So if we want to really clean this up, we have -3 plus or minus the square root of 13. This is a perfectly fine answer. I'm okay with it. This is just a better one. It's more clean looking. Okay, and the last question here. Number 4. You may want to pause the video and try this one or some other ones on your own. Okay, so we're going to find A, B, and C first. Looks like A is 3, B is -9, C is 5. I'm going to rewrite my quadratic formula. If you're getting good at plugging in your values into the quadratic formula, you can skip this and you can just go ahead and start plugging in right away instead, but I just like to show every single step. And if you're the type that makes little mistakes, you probably should do this as well. Okay, so now I'm going to plug in these values, making sure to put them in parentheses when I plug them in. So we have -b, which is -9, plus or minus b squared minus 4ac all over 2a. Got everything plugged in. It's looking crazy, but I'm going to clean this up by starting with the discriminant. Okay, so let's see. We have 81 minus 60. So that ends up being 21. And again, now I'll just plug that right into my calculator. Just save yourself some time. Okay, so now I can clean this up a little bit. Let's see, a -9. We talked about this. That's just going to give us a +9. Bring down my plus or minus. I have the square root of 21 over 2 times 3, which is 6. All right, the square root of 21. It's not a perfect square, but maybe we can simplify it. Let's see. Could use 3 and 7. Looks like that's it. Those are both prime numbers. Those are both singles. So we actually cannot simplify the square root of 21. doesn't look like there's any further simplifying we can do. I can't simplify the 9 over 6. I can't reduce that fraction without also reducing this 1 over 6. Remember, there's a coefficient of 1 right here. So we can't do a triangle method. We're just going to have to leave it just like this. That would be our final answer.